someone post in the chat if you can microphone. How much? Let's turn this garbage off. Bang! How about now? Yeah, I always have to kick the volume up massively. I need to get a better headset next time. Cool. I have this noise gate thing on because I think people can hear me breathing. Huh. 16 people. I'm not expecting too many, to be fair. People are really easily scared by C++. That or I'm just not very good. Which you'll probably find out in a minute. Scared by C++. It's really not that bad. I've only been doing it since sort of April last year. Everything I've picked up, I picked up through Unreal as well, so I'm by no means an expert when it comes to C++. But occasionally I do stuff that works, so... Right, I don't think we're going to pull in many more people, so I will crack on. If anyone comes in late, I'll just explain some stuff to them. So, what are we going to do? We are going to build a flexible camera system in C++. So, basically, the idea is that I see a lot of people trying to make shooter game into a first and third person game. There is actually a tutorial on the wiki which I followed through, and I found it a bit difficult, and some of the stuff seemed a bit counterintuitive, so I kind of experimented with doing stuff my own way, because I needed it for a game that I'm working on, which I'm about to show you. Set up to 2. So I will hop in and explain a little bit. So this is like a little hobby project I've been working on for a little while now. Some people have probably seen some of this. It's basically a hobby type game. Eventually it's going to have some things like real-time strategy elements and stuff as well. And people are going to be able to jump into all sorts of different craft. But the main thing is, A, it's multiplayer. B, it's potentially massive multiplayer, so it could go from 10 players and upwards on each team. At least that's the scope of it right now anyway. And not only that, but there could be in any game sort of up to 200-300 vehicles. Whoa, loud. Wow, why is this so loud compared to anything else? Let me turn that down. Oh, shit. That might help. I tell you, I really need to sort this stuff out. Any better now? where was I? I can't remember. Let me start again. So the game is going to be multiplayer. It's going to have potentially up to, 200-300 vehicles in any multiplayer game at once. Players are going to be able to hop out of them and jump into different craft. That some will be controlled by AI, some will be controlled by other players. So I wanted a really flexible system where I could go into first, third, and like chase cam view on any vehicle, but also do that with. Oh, hang on, I'm trying to get out of this thing. But also do that with the actual pilots as well. So there is a first-person like personnel aspect to the game as well, where people can jump out and look in different views of their character. And think about it this way, it doesn't really make much sense for me to have 300 vehicles in a game, each one with its own what's the word, camera spring arm and camera all attached to it, because 99% of the time that's just processing power that I'm never going to be using. Drive that thing over the stairs. Okay, I've been messing with the physics on this a bit recently, so it's kind of screwy, and it's really sensitive to the ground as well. But yeah, it's getting there. There's this really weird issue with physics right now, where if I look up at all, I start getting extra like spin rotation, which is really annoying. But that's for another day. That's quite loud. So let me just show the fact that it actually does work in multiplayer. Oh, I didn't want to do that. 2 players. This is so cool. This thing. So shake it off to the side. Actually, let's not do that. It's all completely local, there's no latency, nothing like that, and the best part is this scales like super massively, so I can have like 10 players in here all with their own views, and they can all hop out vehicles and do other stuff. By the way, I should also explain, the reason this guy's levitating is I'm using 4.7 and there's currently a bug with pawn possession. It's been fixed in 4.8, Unreal have sorted it out. I think Zach Middleton sorted that. So don't worry about that. I probably won't be able to show that side of things working, but you at least get the idea. Hang on a second. Ah, right. Sorry about that. Been disturbed. BZ game equals Battlezone. Yeah, you're actually spot on. The game's based on Battlezone 2, a game I used to sort of play, well, a lot. It's kind of what got me into game development, actually. Super amounts of modability. So, how does this all work? So the way I've set it up for this, each kind of vehicle and each pawn in the game is going to have loads of different variables that they all share. So they're going to have things like health. All the pawns are going to be able to have weapons, like the characters and the vehicles. They'll all have weapons. They'll all have like certain behaviors and properties that I want them to be global, you know. So rather than doing interfaces and stuff which are really complicated, I don't really understand them very well, instead I just did a custom component called a game object component, which stores all sorts of different stuff like what weapons it's currently got, how much armor it has, different data about the camera. So there's some stuff about the camera there which we'll look at later, resource cost, all that kind of stuff. So the first part really is making a custom component that handles all that. I'm messing around with my blueprints now. So this is, I really do not like this new blueprint editor. Let's hide that arrow as well. It's a bit debugging stuff. So this is a tank, and as you can see, there's no camera attached to it. There's no spring arm. The camera and the spring arm is all managed by the player controller. So if you don't know what a player controller is the actual representation of the player in a level. Still having too many problems with audio. I'm hoping it gets better over time. Let me turn it up a little bit more. It's crazy how quiet this thing is. Let's smack that up to 8, see what that does. Rest in peace, headphone users. That's what I was saying. So yeah, player controllers. So player controllers are over a network. They're also local to each player. So the server has a player controller for every player that's currently joined to the game, whereas a client only has a player controller for the local player. If you're playing split screen, so if you have 2 local players, there'll be 2 player controllers, but most of the time obviously you won't be doing that, so it'll just be a player controller per client, and that is the actual player themselves. That's almost as low level as you can go. You can go a bit further, but we don't really need to do that. And the player controllers also have a physical presence in the world as well. So if you might not be able to see this, but if I hit play, eject, this probably isn't going to show, is it? Let's get the scene outliner up. World, oh, they've renamed it. World outliner now. So somewhere in here is player controller, BZ Game player controller. So that's my custom player controller, and right now its viewpoint is somewhere around this area of the tank, and that's because in this version the player controller has a camera and a spring arm attached to it, which is where all this unique stuff comes from. A few other classes you probably want to know about are the player camera manager. So the player camera manager is responsible for making sure that the player always has something to look at, so they always have a camera or a viewpoint that they're looking through. If one doesn't exist, then it will create one for them. It will actually spawn a camera in the world, and that player will be looking through that camera. What else? Oh, another thing the camera manager does is if your pawn, so say this tank right here, if I was to add a camera component to this, when I start playing and when I actually take possession of this pawn, the camera manager will say, okay, that pawn has a camera, so that's the one that you want to be looking through. The camera manager automatically takes care of things like that. But we need to change a little bit of the behavior, because the camera manager doesn't automatically pick up a camera that's attached to the player controller. Let's stop playing a minute, 'cause I know people have trouble hearing me when that's on, so... What else have we got? What other custom classes have we got? Ah, okay, so the last thing we've got is a custom spring arm component. I saw someone just asked about this in the chat, about the collisions for the camera. So, by default, if I was to attach... Let's go back to the viewport. If I was to attach a spring arm to this... Let's drop one in quickly. I won't save it. So here's my spring arm. It's a bit small. Let's make that a bit bigger, just for lols. So if I was to attach a spring arm to this, the spring arm has a collision on it, which basically... So, how do I describe this? I mean, most of you will probably know what this does, but as you back up to a wall, the camera, rather than clipping through the wall, it'll actually move down the spring arm towards the end. That's done via a collision. So the problem is if I have a spring arm on the player controller, it doesn't know what object I'm supposed to be ignoring. So right now this spring arm knows that it has to ignore this actor because it's part of it. But if that spring arm is part of the player controller, it doesn't know anything about this pawn, and so it won't ignore it. So what will happen is you'll be trying to go into third person view, but you actually end up somewhere like this, and that's because the probe for the spring arm is smashing against the back of the collision of the object, which obviously you don't want. So there's no way to pass in a specific actor to a spring arm, but it's really easy to create one. We just create a really simple spring arm component. We just need to override one function. So, by the way, I'm sorry I'm not keeping up with the chat very well. It's really hard to talk and read at the same time. As we know, men can only do one thing at once. So, where do we begin? Let's look at some code, because that's what everybody's here for. So, what do we want to do first? Do we want to do our player controller, or do we want to do our camera manager? Well, I'll tell you what, let's actually create a new project, because that would make sense, wouldn't it? So, let's get rid of this. I'll probably want to keep it open. So, I'm going to create a blank C++ project. Don't want any starter content. Let's bung it somewhere where I've got plenty of hard drive space. E drive, users. Why has that got a lock icon on it? That doesn't make any sense. Unreal projects. Oh, can I call this piece of game as well? No, I can't. That would make copy and pasting too easy. Let's call this stream game. I'm super imaginative when it comes to names, and create that project. Although I'm sorry in advance, there's probably going to be a little bit of boringness when it comes to compiling this stuff. That is the nature of C++, unfortunately. So I've explained a bit too much in a short space of time, so I'll go over things quickly again while this is doing this. We need a custom player controller that has a camera and a spring arm on it, so I can jump into any vehicle and any pawn that I want, take possession, and figure out where the camera should be. I also need a custom spring arm so that I can tell it I need to ignore that pawn when I take possession of it so that the camera isn't stuck inside. I also need a player camera manager, so I need to change one of the functions so that it picks up the camera in the controller. And I also need, finally, a custom actor component which I can give to any pawn, and the player controller will read from that component and then say, right, I know where the camera is supposed to be, it needs to be here. This is where I wish I had a 20-core processor or something ridiculous. Let's have a look here. So, in fact, I'll have a look through the chat. So, last question posted was, oh, okay, yeah, I can get rid of this. Leave me alone. Da, 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 da. Yeah, you can save that. Goodbye. Right, so this is our new project. Someone's just, Claude was just asked, why am I creating a project with some C++ code in it? So I know I need a, oh, excuse me. I know I need a custom player controller and a custom game mode, so I might as well just use some of the stuff that's already here. So let's go into, oh wow, the launcher's going crazy. This is where 2 monitors is just not enough. Let's move this over. So what's the first thing I want to do? I want to compile the project. That'd be a good start. There we go. So just because I'm old school, I'll tell you what. Right, so I'm going to add some code to the project. So what am I going to do first? Tell you what, let's do the spring arm first, because I'm going to need that to do the player controller anyway. Shell classes. So we're going to base this off the existing spring arm, because there's no point reinventing the wheel. Spring arm component. Next, we'll call this, stick it in the right folder. Oh, I've just thought of something. I'm going to have to include loads of things, aren't I? Right, I'm going to be really messy with my folders. Sorry about this. So I'm going to call this stream game. Stream game. Actually, let's not do that. Let's just call it something. So let's call it assignable spring arm. Can't spell component. So that is going to be our, actually, better idea. Let's call it stream spring arm component, because that's easier to type. So stream spring arm component. This is going to be our custom spring arm. Let's create that and add it too. Also, I don't know if anyone's seen this, but oh, I know why this is happening. So in 4.7 they've added something where as soon as you add a class to the project, it will compile your code. I have no idea why, because that class has absolutely nothing in it when it's created, so I hope that changes in 4.8. It does an auto hot reload now as well. That's interesting. So now I need to go and edit the code, so that was kind of silly. Let's move this over here. I don't need to look at this. Son of a spring arm. Okay. No, wrong one. There we go. So, here are my new classes. So, the function that I want to override is called update desired arm location. So I'm just going to copy and paste that from here. This one. So it's a virtual function, so we can override it, and it takes in a few parameters like whether or not we want to actually do the trace or not, how much rotation lag there is, and delta time, things like that. And then I want to do two other things, so I need to add a public function called, what should we call it? So before we do anything, let's make it a U function, because then this is always good practice, because then anybody that's doing Blueprint can use this function later and do something crazy with it. Let's not call it that, let's just put it in a spring arm category. So I'm going to create a function called setAttachedActor, and I want to pass in a pointer to an actor. And what this is going to do is, from our player controller, this is going to let us talk to the spring arm and say, right, I've possessed a new pawn, I now need to tell this spring arm what that pawn is so that the camera trace ignores it. And then lastly, I want to make a, let's make it protected. I want to make a protected variable which is the attached actor. And that is all we need to do in the header for this. Easy peasy, lemon squeezy. So let's create the actual functions for these. By the way, if nobody has Visual Assist, I feel so sorry for you. This program is amazing. Visual Assist is like a like an extension plugin for Visual Studio, and it makes all this stuff so much quicker. So before I override this function, let's do the setAttachedActor. This is really simple. All I want to do is actually set our variable to the incoming actor. So let's comment this because that's good practice. So the player controller is going to call this and sets the ignored actor to the pawn it's possessing. And I could just pass in a pawn like that, because I know that the player controller is only ever going to be able to possess a pawn anyway, but just because I want to keep this super flexible, I'm just going to let it pass in an actor. It doesn't really make a difference. So update desired arm location. This is the function that actually performs the collision and tells the camera where it needs to be along the spring arm. So let's say this is a UE function, and it updates the camera's location. So by default, this is so cool that they've included the C++ source in this now. Let's just search for it. Spring arm. By the way, if people can't see the text, let me know and I'll zoom in a bit. I know over this connection it's probably not massively readable to everybody. So Unreal's done this amazing thing with 4.7 where they've actually included the C++ files with the engine, so I don't have to go to GitHub and download it anymore. So I'm looking for a function called update desired arm location, which is not that one. Yes, it is. So let's walk through this and see what it does. We don't need to worry about any of this. Forget all that. If you want to know what that does, you can look at it later. The part that's important is it. right here, which actually looks like it's changed a bit since I last did it, but never mind, doesn't matter, it'll still work. So what we're basically doing here is a collision check. So this is the part that says, this is the part that basically, well actually this part right here is the ignored actor. So what we can do when we do a collision is you can pass in an actor. Yes, we can't see. Okay, let me make it bigger. How about that? Wow. That is horrible to look at, but if it makes it easier for you guys. Let me just wait a sec, so let the stream catch up. By the way, if I'm talking too much, even though that's kind of the idea of a tutorial, if I'm going into too much detail or doing a bit of too much information, let me know. That looks better. Good. Okay. So, let's do this again. So right here, this is where we actually do the collision. So this is where the spring arm actually says, right, get the owner of this particular component and don't use that in the collision. So basically, when I attach this to a pawn, it'll ignore this, it will actually ignore that pawn altogether, so it won't check against it, which basically means the camera will move irrespective of where that pawn is. But it will, if you back up into a wall, the camera will slide down the spring arm so you get nice, you know, you don't clip through stuff. That is this bit right here where it says get owner. Now rather than get owner, I actually want to pass in a specific actor. So in our case this will just be the attached actor, so all I need to do is, let's go to our spring arm component and zoom in a bit. So I'm going to copy all the code I've done before because I'm a cheat and chuck this in. So let's walk through this. Let's go back up to the top. So before I do anything, so I'm overriding this function, which basically means I'm changing what it does. Aha, this is a problem. I'm going to have to add a player controller. Okay, so in the Battlezone version of the game, what I do before I do anything is I check whether the owner of this spring arm is a player controller. If it is, then I do all this overridden code right here. If it's not, then I call super at the bottom, which basically means do whatever the function did before I overrode it, which is really useful because it means I don't have to copy and paste all sorts of stuff. The only thing I've changed, where are we? So yeah, so if I go back down to where the collision is, the only thing I've changed down here, so we've still got get owner in the collision params, but I've also added, if we have an attached actor, so if this variable right here is valid, then it will also add an ignored actor to that collision query. So basically what it means is, not only will it ignore whatever this spring arm is attached to, but it'll also ignore the actor that the player controller tells it to ignore. Okay, so what that means is when I go into third person, my camera isn't going to get stuck against the inside of the mesh, which really tripped me up for ages, so I'm showing you this now so that you don't do this in future projects. So obviously, by the way, before I say anything, this code will all be up on well, the video will be up on YouTube, and if anybody does want this, I'll put the project up in the tutorial thread as well, so you guys can look through this at your own leisure and figure out what's going on. I'll add some more comments as well. And we've got one problem. I can't compile this because this project has absolutely no idea what a BZ Game player controller is, so I need to add a custom player controller of my own, because the default project doesn't come with one. So let's do File, Add Code to Project, Camera Manager, I need that later, Player Controller, let's call this Stream, Player Controller, and create that. It's going to try and compile and it's going to fail. I really hope they get rid of this auto-compile in 4.8. I don't know why they thought that was a good idea. Yeah, cancel, go away. Okay. Let's close this search. There we go, there's our new player controller. So, do I have to fart around with any includes of any kind? Don't think so. Well, too many things open right now. Let's close all these. Spring arm components. Let's change this. This is going to be a stream player controller. So if the player controller that owns this is a, well, if the owner of this object is a player controller and it is a stream player controller, do all this new stuff. If it's not, just do what the original spring arm did. And that's it. That's a spring arm component. So now I can use that anywhere I want. I've just noticed a few things I'm going to have to do before we continue. So if you want, this tutorial is rapidly getting out of hand, but if you want multiplayer in your game in C++, if you want to work with any of the network stuff whatsoever, you actually have to add the Unreal libraries in the build.cs file. Again, some of you probably know this, but just so it doesn't catch people out, let's do this right now. So the way we do this is we go to the dependency module names and we add online subsystem. You can't see this, can you? It's better. Online subsystem and online subsystem utils. Notice the capitalization on those as well. It's quite important. The other thing we need to do, some other stuff, is uncomment this. Okay, my shortcut didn't work, never mind. So we can uncomment this stuff. By the way, if anyone's got any amazing Visual Studio shortcuts that they know, please stick them in the chat because they are always useful. Oh, I don't really want to uncomment that, do I? So we also need this stuff. It has the comment there. Uncomment this if you're using online features. So all this means is we've added all the online libraries to our project now. I'm pretty sure if I do this I have to close the editor as well, which is fine. And I need to do one other thing. It escapes me right now. Yep. So the other thing you need to do if you want to get online functionality is go into the header file for your actual game and need to include a few more libraries in here. So let's add included for online play. I hope people are following, by the way. The chat's gone real quiet. So I need to include net / Unreal Network.h. I think that's it. Control KF. Oh, that's the format shortcut, isn't it? Someone taught me that the other day. Best one there is. The only thing I don't like about it is if you have an if statement, it tends to like stick the sticks the square bracket on the end like that, which is horrible. Who writes like that? So that's that. So now all I've done there is I've just added all the online functionality to the game. I'm probably not going to go into the multiplayer stuff in too much detail. I will show you the code and show you briefly how it works, but I'm not going to go into too much detail with it because that's like a whole nother ball game. That's like another stream altogether, multiplayer. So what shall we do next? I guess we should do the player controller, since that's the next most complicated bit. And since I've got it open. So like I said before, the player controller is the physical representation of a player in the world. So whenever a player logs into a game, whether it's single player, whether it's multiplayer, they'll have a player controller associated with them. Now, the reason I'm putting the camera and the spring arm and the player controller is because remember what I said about the game that I'm working on possibly having sort of 200 or 300 vehicles or pawns in the world that I can possess at any one time. It's kind of pointless for me to attach a camera and a spring arm to each one, especially if I know that I've got shortcut bindings for going into first, third and chase camera view. You know, it means I'd have to like go through an interface, I'd have to do loads of casting everywhere. So it makes more sense. Oh, and on top of that, it also means I'll be, you know, processing all those spring arms with collisions and that camera constantly all the time, which is a massive waste of time. There's absolutely no point. So it makes more sense to do it here for the player controller. So every player is always going to have a camera. So, what do I need to do? I need to have a look at my other code because that's how it works. Player, sorry, I'm doing some stuff off screen right now. Player controllers, open that, and the player controller. So, one thing I'm just going to add quickly, I'm going to cheat a bit. In 4.7, so you notice what I just did, I changed generated body to generated U-class body. I wouldn't recommend doing this, but I'm only doing it because I'm going to be a bit cheeky and skip out some of the stuff that 4.7's done. So it used to be whenever you did a server function, I mean most of you guys have probably seen this if you do a multiplayer, but if I was to do a server function like this and all the nonsense that comes with it, let's just call this server do stuff. What you have to do in 4.7 now, if I got rid of U-class body and change that back to this, you now have to do all the extra ones yourself, so virtual void, server do stuff, implementation, and virtual bool, server do stuff, validate. So those two functions there are where you actually do the code. For some reason in 4.7 they took out the automatic generation of those, so you actually have to explicitly type them in now. I don't know why, I'm sure there's a valid reason for it, but no one really knows what that is yet. In fact, I'll tell you what, because we're on 4.7 and that's probably not going to change, let's just stick with doing it this way. So ignore everything I said in the past like 10 minutes. So, what do I want to do? Right, the first thing I need to do is include that spring arm component that I just made. Otherwise it's going to have no idea what it is. So it's called stream spring arm component. And let's make a protected component. Zoom around a bit here. So I have so much code in this other player controller that isn't relevant to this. So let's comment this stuff. So these are going to be the two components that we use for the actual viewpoint of the player. Just copy and paste them in. So name a couple of things. Stream spring arm component. So what have we done? We have created. Oh, let's not chuck those in there. Player controller. Yep. So we've created two. We need two components. So we need the camera, which is just a U camera component. It's just a standard Unreal Engine camera, and we need the spring arm for the camera as well, because we want to do third person and chase cameras as well, which is our custom spring arm component. So whenever you do stuff like this, you should also write. Well, you don't have to, but it's a good idea. You should also write accessor functions so you can actually get to these. Obviously they're protected components, so if I ever want to get to them from another class, I need to use a function to actually access them, which is generally considered good practice. So let's call these accessors. Oh wow, I cannot spell. So those are the two accessor functions. They're just inline functions, so we don't have to do anything in the C++ file, and they're also a bit faster as well, and they're always going to return the same thing, so it just makes sense to do them as inlines. And all they do is, whenever another class calls getViewCamera, it will just return a pointer to the actual view camera. Easy peasy, so I can do stuff with it even if I'm not the owner of that object. So that's our two objects. One other thing I need to do is I need to actually construct them. This always messes me up in 4.7. So I'm going to have to look at like a base No, actually, no, I'm not. I've got some somewhere. So in 4.6, I believe, they added the ability for people to not use constructors, or they changed the way constructors were done, or something. So you actually, if you want to make a constructor, you have to override it now. I'm looking at the wrong class. You do that. Oh yeah, that's it. So on a public constructor, you know, I can already tell this tutorial is going to go way over an hour. Constructor for this class. So this class is a stream player controller. We need to use the old object initializer stuff. That's it, as our constructor. So now, thanks to the magic of Visual Assist, I can just create that in our CPP file. So let's actually set up the camera and the spring arm so it knows what those two things are. So I need to call super on the constructor before I do anything. And let's go back to our player controller. So I'm just going to copy this in from my just going to copy this in from my other class. Bang, stick that in there. Will you put recording this on YouTube? Yes, I will. Don't worry, this will all be on YouTube later. So all I'm doing here is actually creating the camera spring arm. Let's call it the stream spring arm, so it actually lines up. I'm creating the spring arm for the camera as a component of the player controller, setting the arm length to 0, turning off things like use the pawn control rotation. Oh, excuse me, turning off inherit pitch, yaw roll, etc., because the player controller doesn't have any of those things. Also going to turn off camera lag for now. And this is the important bit at the bottom here. I need to set net addressable, okay, so that a server or a client can call functions on this thing. And then I also need to set up the view camera. It's really easy. So view camera isn't that far-fetched either. It's just creating a camera component. I'm then attaching it to the socket on the spring arm. That's how you do that right there. Set its relative location to 0, and then again make sure it's net addressable. And that is about it. Oh, the only other thing I need to do, so this class has some replicated properties and functions, or at least it does in my original game. So I'll check this in. So I want to make sure this class replicates, so just set bReplicates to true, or you can call setReplicates true, like that. Either one doesn't really matter. So that's that. So now our player controller, I'll tell you what, let's actually show you this. So I'm just going to build it, and this is where loads of errors will come up. So now our player controller will have a spring arm and a view camera. And when the editor loads up, I'll create a blueprint of it so I can show you that I'm not just lying to you. It's worth remembering as well that there's like a million different ways you could do this kind of system. This is just the one that worked best for me. You know, I already had an actor component that was going to have loads and loads of variables in it, and it was going to be part of every single pawn that I could possibly take possession of, so it made sense for me to do it this way. I'll get to the component stuff in a bit. Come on. This is where we need to look at pictures of cats or something. This is probably going to take a bit longer than usual actually, because it's adding all the other stuff. Oh, yeah, here we go. I've already broken it, look. So, a stream player controller. You don't know what a stream player controller is? Let's fix that. Oh dear, so what am I missing here? Yeah, so the problem is the the spring arm doesn't know what my new player controller is. This isn't a problem in my other game because somewhere along the line player controller is probably included in something else. Just have a look at springarm.h. I imagine what I'll have to do is include that as well. Yeah, okay, but one thing we did earlier is going to screw around with that. So in playercontroller.h, I've already included springarm component. So what's going to happen, if I chuck that in here as well, I'm going to get a circular dependency and my coders are going to compile. So the easiest way to get around that is just do a for declaration. And the way you do it is just type class a stream player controller. All this line does is it basically, it's hard to kind of describe, but when C++ compiles, it kind of does it in pieces, it does it in separate modules, and then it kind of smashes everything together at the end. The problem is while it's compiling, it might not necessarily know about some parts in one of the other modules. So what you have to do is tell what this for declaration does is say at some point you're going to come across a class that's called a stream player controller. When you do, just replace, not really replace, but when you do, you know, this is what it is. But basically all you're telling the compiler that this exists, don't worry about it, I know what I'm doing. Now let's hope this compiles, because if it doesn't, everything I've just told you is going to make no sense. Oh, look at that. Oh dear, what's all this? Extreme underscore player controller. Have I just spelt it wrong or something silly like that? Live demos, people. Live demos. Oh, my forward declaration didn't actually work. That's annoying. Maybe I need to get out of this by doing it another way. Let's just risk a circular dependency for a second. Spring arm component. Oh, sorry, I want. Oh dear. Include stream player controller. That needs to be there. I might actually get away with this circular dependency thing, because this is, yeah, I will. Because I included the header in the C++ file and not in the header file, I can get around that circular dependency. There you go, that's our first glitch for the stream. Damn load times. Oh, there we go. So, now if I make a new, let's make a new folder. Stream stuff. Oh, yeah, no spaces. New blueprint. I'm going to base this off of our player controller that we just made. So here's our player controller in blueprint form, and there you go. We have a camera, and we have a spring arm. Super! So that worked. That's good. That's progress. So let's stop debugging that for a while. Right, so what's the next step then? I suppose, what should we do? I guess what we probably want to do is just create all our base classes first. So I just closed the editor, that was silly. Let's open that up. So what I'm going to do is create a... what do I do this? Do I do this with a character? Let's do it with a character because they already exist and they're nice and easy. I can steal content as well. Delete that. So I'm going to add some code to this project, base it off the character class. You can base this off pawn, or you can base it off character. I'm just going to do it off character because we've already got things like movement and stuff like that, and it just, you know, it'll make this stream a little bit more entertaining. So let's call this stream character, create that bad boy, wait for code to compile because why not. There we go, and here's our new character. Oh look, it adds, oh god, this is all new. So it comes with some existing functions now. That's all new. So one other thing I'm probably going to want is actually some content to visualise this character, aren't I? Because right now it's got nothing in it. Actually, we'll do that later. So where's the constructor for this thing? Here. I don't like this new stuff, I've got to say. Let's get rid of... Oh man, so many things have changed. Okay, character class. What do we need in our character class? We need a third person mesh, we need a first person mesh, so let's make these two protected objects. I want a skeletal mesh, I guess. So character already comes with a third person mesh, it's just called mesh, but I also want a third person mesh, sorry, a first person mesh. That's my accessor, why is that there? So that's the function that's going to return the mesh, and I actually need the mesh itself. There we go. So I've just created a skeletal mesh component, and that's going to be the first person mesh. So that'll be like your arms, or it'll be your cockpit, or whatever. Let's make the constructor for this. So how did I do this last time? A stream character, see if I can get this right. Const f object initializer. I think that's it. Oh, it's a pointer. I don't want a pointer. There we go. Right, so let's make sure ticking's turned on. So what else do I want to do here? So let's set up the meshes. So the first thing I want to do is set up the first person mesh. And in fact, why type everything out? You can just copy paste. It's the first person mesh. All I'm doing is setting a few basic properties on here. So we only want the owner of the character to see this mesh. We never want any other players to see arms floating around in midair. We don't want it to cast any shadows, we don't want it to receive any decals, we want it to tick the pose but only when it's rendered, so it's a bit of an optimization, tick groups, blah blah blah, and turn off all the collisions. So that's all we're doing on the first person mesh. We also want to do some stuff with the third person mesh, so getMesh is a function that exists as part of character, and we're doing a few things with it. So we're setting the visibility of it, so only people that only other players can see this mesh, whereas the actual player can't. And we're also turning off the collisions, and we do want to cast a shadow even if the mesh is hidden. So that's our character stuff set up. Let me just scroll through and see what other things we can set up here. So I don't need to do that on tick. Player input component. Oh, I suppose I should set up some input. That'd be useful. So, we don't need jumping. Actually, I'll tell you what, let's scrub that out for a minute. We'll come back to movement later, because it's not really important for now. Right, what else can we do in our character before I move on? not an awful lot really, so that's you. The other thing we need to do is add a game object component. So the component is the part that's going to basically determine where the camera attaches. So whenever a player controller possesses a new pawn, it's going to try and get this component from the pawn it's possessing. If it doesn't do it, then it will do whatever it normally does. But if it finds this component, then we want it to tell the player controller where the camera needs to be, or like what it should be attached to, what view you're currently looking through, etc. Obviously there's loads of different ways you can do this. I'm doing it through a component just because that's the way that worked best for me, for my game. So let's do add component. Let's call this stream game object component. So let's create one of those. We need to add this component to all of our classes that we want to have this like first and third person functionality. Here we go, as our new component. Oh man, so much stuff. I kind of miss it when you created a class and it had nothing in it. Oh, okay. So I'm doing some off-screen things. Let's turn all this off. I don't want any of this. So what do I want to do for this component? The first thing I need to do is actually tell it what the owner is. So when I put this component on a pawn, so say for example this game object component can be attached to other things, so it's got like a health variable, for example. What if there's a crate or something in my level that I want to have a health variable, but I don't want to be able to possess this thing, so it might not be a pawn. So I need to basically tell the player controller that I am in fact a pawn, if that makes sense. And the other thing I want to do is actually have a constant reference to that player controller so I can talk to it. So let's string player controller. So what these two functions are going to do is just allow me to set those two variables. So I'll set those up now. I'm pretty sure they're just called. Yeah. Old school comments for the win. There we go. So these are two replicated variables, which are the pawn owner and the controller. They're replicated for the sake of the whole network play thing. So let's just set up these functions. And delete all the garbage that it comes with. Should be cool. Oh man, constructors are so weird now. So. Oh. Ah. Okay, so let's set pawn owner. So in set pawn owner, all we want to do is, if the existing owner doesn't equal the new owner that we tell it, then set up the new owner. And we want to do the same thing with the player controller. So now I can always tell this component what the, well, let's word that another way. This component now always has a reference to the pawn that owns this thing that I can then get from other classes, and it also has a controller that I can get from other classes. Minimize this stuff. Or I can, you know, for example, I can read parameters from the owning controller. Bang. Okay. So anything else I need to do? Suppose we could talk about mesh stuff now. Yeah, okay, so there's some differences when it comes to first and third person. So in first person mode, you want to be able to see the arms and the weapons and stuff like that. When you're in third person mode, you don't want to see that. You want to see the actual character's mesh. When you go into third person mode, you want to hide the first person mesh for that player, so you need to do some functionality with that. So let's plug that in. What I'm going to do is... How shall I do this? Okay. What I did in the old version, if I just drag it in, I had this function called update object meshes, which basically the component keeps a reference. I'll zoom in a bit. The component keeps a reference to the first person mesh and the third person mesh. The component knows at any time what view I'm in, so it can say, right, if you're in first person view, I need you to tell the object that you are owned by to hide the first person mesh, which is really easy to implement. So this function, I'm trying to think where the best place is to start with this. Okay, yeah. So in the character, oh man, get rid of tick. I don't want tick. Why do I want tick? Get rid of play as well. So in the character, I need to override post initialize components. Post initialize components is basically called as soon as the constructor's finished. So once all your components have been made, you can then instantly perform functions on them before the game actually starts playing. So let's cut this, chuck it in here. So what I want to do in post init components is I want to actually talk to the game object component. Post initialize component. Before I do anything, it's called super on post init components, and then because we're doing multiplayer, I only want this to happen if we're the server. So I do if role is equal to role authority. Ooh, role authority. Can't do anything yet because I haven't actually made a component. So let's actually add our component to the character, which is easily done. That category name stuff. Let's not put it in mesh. Actually, let's put it in game object. Ustream game object component. So all I've done is created a game object component within the character. And I've got an accessor function for that, which is the same as all the other ones. And what else do we have? Need to set that up in the constructor as well. There we go. Stream game object component. So I'm just going to create a component. There's complaining at the moment because there's a function that doesn't exist. I'm literally just about to chuck that in. So let's go to this component and create this functionality. So whenever this component is attached to something, I want to actually I want the owning actor of the component to tell the game object which meshes to update. So to do that, I'm just going to allow the owner to call a function on this which sets those meshes. Okay, so we've got two variables, first person mesh and third person mesh, and those are just references to the meshes that we want to update. So let's chuck those into protected as well, nice and clean. So those are the two references to the meshes that we want to hide or unhide depending on what view you're in, and this is the function that's called by another class which says these are the meshes I want you to, screw around with. Is there any reason to use object initialize or always leave it out? Probably not, but like I said, I'm not much of a C++ guy or much of a wizard. I'm just pretty much copying and pasting code that I've already done here, so rather than run into any funky problems, I thought I'd leave it in. What else do I need to do? Oh, I need to call super on this as well. Well, again, I probably don't, but I do it out of habit. You get into habits with C++. So, when... Oh, there you go, it's already done it. So in the constructor, what I'm doing is I'm telling the game object component, right, this is my first person mesh and this is my third person mesh. These are the meshes that I want you to hide or unhide depending on what view I'm in. And if I remember rightly, I've got it open. Character. So the other thing I want to do is on that game object component, I also want to set the pawn owner to be this object, so we can set that up. That's actually what I need to do in there. Loads of other functionality dotted around all over the place. So as soon as this is created in the world, all it does is it tells the game object, this is the owner, this is the owning pawn, like I am your master. So I could go into game object component and just do get owner, but I'd have to cast it to all sorts of different classes and it just doesn't make sense. I might as well just keep a constant reference to that pawn. So what should we do now? Update object meshes, I guess. Well, this is the point we should probably start putting in some of the camera functionality, I suppose. Yes. Oh no, hang on. I haven't actually implemented this function yet, so let's create that. All I'm doing is third person mesh. There we go. That'll actually set those now when that gets called. So I guess it's time to go back to the player controller. Close this. Close the character. Back to player controller. This is where all the crazy functionality happens. So much code. What's the first thing we need to do before we do anything else? So we've done our construction, got all that in place. What should we do next? I suppose what we probably want to do in the player controller is we want to have a reference to that component. So what I can do is I need to override a couple of functions here. So let's go back to piece of game. So I want to override the possess and unpossess functions so that we can do some custom code whenever we get a new pawn. Oh. So these are public functions because obviously you want to be able to tell a player controller to possess something, so let's chuck those in. So these functions already exist, they're just, they're called and they tell a player controller whether to take control of a pawn or to leave it alone. And then let's create the implementations of these. So these are the overridden functions, and then in CPP, where are we? Possess. So whenever we possess a new pawn, just ignore this part for a minute. Whenever we possess a new pawn, we want to tell this spring arm to attach itself to that pawn. So you can actually do that. Just because this component is part of the player controller doesn't mean you can't attach it to another class. So whenever we possess it, I want to attach the spring arm to our new pawn. And the other thing I want to do is, oh, do I want to do that? Yes, I guess I do. The other thing I want to do is when the, oh no, actually, scratch that, never mind, come back to that in a minute. So that's all that's going to do. So whenever we possess a new pawn, we're just going to attach the spring arm to that object. Now, the next thing we want to do is run a function, attach camera to pawn, where are you? Now, possess, the function possess only runs on the server, I believe. I might be wrong about that. Hang on, let me double check what I've done here. Okay, yeah, so Possess only runs on the server, so there's this really cool thing we can do in Unreal. Attach, oh no, sorry, I should create the damn function first. So I don't know if you've ever seen these, the onRep functions. Basically, whenever this particular function, let's have a look at what it does. Oh, it's got a controller. So this particular function is called whenever a client is synchronized with a new pawn. So whenever this player controller takes control of a new pawn, it has to tell all the other players what it's actually taking control of. When it does that, this function here gets called. So this is a kind of super handy feature with Unreal's netcode. So what I want to do whenever that changes is I want to also attach the spring arm, because this is all done client side. Attach camera to pawn, I might as well untag those. And we also do a get pawn here rather than a pawn, because obviously it doesn't know what the pawn is. Simple so far. Explaining this in probably a bit too much detail. I think we're gonna try and keep this stream 2 hours long, so if I do run out of time, I'll carry on from where we left off next week. So I suppose we might as well write the big important function. So we need a function that actually, do we need to do that yet? Yeah, we do. So we need to do two things. We need a function that basically tells the camera arm where to be whenever I change view. So in first person view, you guys not hear it very well still. Seems to be getting worse and worse, getting lower and lower. Not because I'm getting more and more tired. Why is that? So we need to tell the player controller where to stick its camera whenever I tell it to change view. So I'm going to call this function. Sounds not very good. Ah, that's annoying. Is there a weird sound coming from this, is there? Oh, okay. It's coming up in here as well. I have no idea what that is. Oh, live streaming, people. I can smash it up a bit more. I don't want to push it too much because it'll just, all it's going to do is amplify that background noise as well. Plus I don't want you guys to hear me breathing. That'd be kind of weird. I'll leave it like that for now. If it gets too much worse, let me know and we'll try and take this up another day. I'll sort of fiddle around with my settings in the background. And like I said, all this code is going to be up somewhere eventually, so you'll be able to look through it at your own leisure and kind of pull it apart and see what it does. So what am I doing? So I'm going to create this function called onViewTypeUpdate, and what this basically means is this function, I'm going to call this whenever I want to change the view. Let's have a look. Let's have a look. Yeah, I mean I'm boosting this like almost 12 times now, so it's insanely loud on my end. I don't want to push it up much more because it will just distort and go weird. But again, it'll all be on YouTube, so you better watch it back another day. So on view type update, this is a bit of a meaty function. Let's go through this a bit. Got a lot of extra stuff in here. So I want to swap out a few things. Image from pawn. I haven't put that in yet, have I? So I said I wanted a constant reference to that game object. Do you know, on reflection, what I probably should have done is just walked you through the code that I've already written. Would that actually make sense for more people? I mean, rather than me copy and paste this all over the place and recompiling, would it make more sense if I just walked through it with everybody? Let me know in the chat, because I feel like this stream's going to go on for hours otherwise. Certainly be easier for me. And like I said, the code will be up, so you'll be able to pick it apart. Just let me know in the chat, guys, when that gets through. There's so much delay on this thing. Lol, changing stream topic at the last minute. But please in the correct order. Yeah, it's really hard to kind of copy and paste and do things in the right order unless you've planned it in advance. Alright, I'll tell you what then. Let's completely break it all. Let's stop this. And let's be honest, it looks cooler when you've got something to look at as well. I'll save this just in case you want to come back to it. Close that. Yeah, I want to save all this. Comments would be helpful, yeah. So, did everybody in the stream, did everyone see this from the start? Because if not, a lot of this stuff isn't going to make sense. If you didn't, it's fine, I can go over it again, it's not a problem. Oh yeah, fire this up in Dev Editor. That's fine. Ooh. Yeah, because I think a lot of the stuff I'm going over in this, you know, if you guys are already doing C++, you probably know a huge chunk of this already. You know, creating components and stuff like that. That's relatively easy stuff. Yeah, let's go over it quickly then. Alright, let's fire this up. I do C++, but I don't know anything about it. Yeah, welcome to my life. Yeah, I've only been doing C++ since April last year, so I'm not really in any position to be teaching this kind of stuff. I should stick to what I'm good at, like materials and things. Although I say that last time I did a stream, I forgot how to do something. Alright, let's go. Let's show you what all this code is supposed to be doing. Let's just stick with single player for now. Right, I hope this isn't too loud because I smashed up the volume and this is probably going to destroy people now. So I'll try not to press the fire button even though it's really tempting. So all I'm doing is I'm hitting I, O and P and I'm just changing between third and first person. I'm changing between first and third person views. That's literally all this code is doing. However, the beautiful thing about it is I can go into any other pawn, so this character for example, and I can do the same thing. But what you'll notice is the the position is determined by the character. It's not done by it's not done by the player controller. It's actually done by a component that's attached to each pawn. That jump sound. So you can actually see at the top left, it's probably a bit small, it's probably a bit hard to see, but you can see at the top left it's got attached to and pawn name, and that just tells me what my player controller is currently attached to. So I'm currently attached to Derp Tank 2. Okay. And it also saves my views. If I hop out, I'm back in third person. I go to shoulder cam and shoulder cam, first person, first person. And it's all local as well, so any client can do this on their machine. Someone just said, how come you're doing this in C++? So the reason I'm doing this in C++ is because I'm doing, for this tank, if I hit play, I'm doing a lot of fairly complicated physics stuff on this. So all the movement, it's not based on world position updates or anything, it's based on physics. There's some line traces and stuff going on for the hovering. There's a lot of math calculations going on. So it just made sense for me to do it in code, and not only that, but code was a lot neater as well. You try and do this kind of stuff in Blueprint, and the node graphs get so at hand, and it basically makes things unreadable. One thing I've been told recently is, as a programmer, the most valuable thing is your time. So if doing it in code is quicker, just do it in code. But oppositely, if doing it in Blueprint is quicker, do it in Blueprint, because they're practically equal to each other. How have I done all this magic that I've been trying to explain for the last hour? So really simply, all I've done, in the vehicle we've got this, a game object component. Okay, so this is a custom actor component that I've coded in C++ that is attached to this vehicle. Oh, wow, that screen got messy real fast. Class defaults. Let's try and rearrange things a bit here. And this actor component has a few different variables on it as well. So if I go under camera, oh no, sorry, not camera, where are we? Pilot? Nope. If I actually had the thing selected. So in the game object component settings, I have what's called here game object camera data, which is just a bunch of variables that I can change. So let's say, for example, I have another version of this tank, and I want the, and it's massive, so I want the camera to be really far away. Let's change the chase camera to be sort of, I don't know, let's make the arm length of the chase camera something like 6,000 units, so it's absolutely massive. Compile and save, and then when I hit play and go into chase cam view, wow, look how far away I am. Okay, and the spring arm still works as well. So subsequently I can do the same thing with the shoulder cams. Let's change this back to 2500. Let's make this, I don't know, actually let's make that 750 still. Let's, I don't know, offset it to the right a bit. So in shoulder cam, let's say I literally want to be on the shoulder, so let's do Gears of War style. Let's offset it to the right a little bit. When I go in the shoulder, that's a bit too Gears of War, but when I go back in the shoulder view then, I'm actually slightly off to the left. So that's all that component is doing for the sake of this tutorial. It does a hell of a lot of other stuff as well, but that's the main stuff we're looking at. So let's have a look at that component in code real quick. Oh, before I do that, one other thing you'll probably notice as well is on here, or I guess not so much on this, but on the actual character, whoa, open the blueprint editor, so viewport. So you'll notice on the actual character there's two meshes. There's the there's the mesh, which is the normal third-person mesh, and there's also the first-person mesh. Someone just says, so the cams are attached to a mesh structure. No, the camera is part of the player controller. That's the key difference with this. So as you can see here, there is no camera whatsoever here. The camera is actually part of the actual physical player in the world. So there's the, sorry, let's go over this again. So there's a third-person mesh, there's a first-person mesh. Now I want to swap the visibility of these whenever I go into first and third-person view, and the custom component, the game object component, manages that itself as well. So that also takes control of that. So if I want to create a new pawn, let's create a new, actually let's not do that, let's just create a new vehicle because that'll be easier. Yeah, let's create a, yeah, why not? Let's create a new vehicle. So I've got loads of different classes in here. So this is just my base vehicle class, which already has a game object component attached to it. So any vehicle that I create automatically has all of this new functionality, and it's the same with any custom characters as well. But the cool thing about it is, if I just want to use the default pawns that Unreal comes with, I can create one, and then all I have to do is add my custom component in here. Oh wow, but I can't because I haven't exposed it, of course. Where are we? Live demos. Okay, so I can't because I haven't exposed it, but if I was to go into components, and if I added blueprint spawnable component in the uClass thing, I'd actually be able to attach that to any actor. I imagine the reason I haven't already done that is because I'll never need to do that in my case, because everything's going to be done in C++, just because I'm old-fashioned. I'm not even old-fashioned, I haven't even known code for a year, but, you know. So, there's no need to stop debugging, let's walk through this a little bit. So, let's go to the player controller. So, in the player controller, let's keep this a bit shorter and sweeter than we were doing before. In the player controller, I've created some inputs. So, these inputs are global then to any player, so they're not part of the pawn, they're part of the actual player controller. So, if I hit the first person view button, I want to call the first person view function. Shoulder cam view calls the shoulder cam function, chase cam view calls the chase cam function. And in editor, these are just by, where's the input settings? These are just bound to the I key, the O key, and the P key. This might change later, I don't know, but whenever those are pressed, that player controller will call those functions. So that means that's global to anything that I take possession of then, because it's part of the player controller. So let's have a look at what those functions actually do. So let's go to on first person view. So what it does is on first person, oh sorry, I better zoom in a bit here so you guys can see this. So on the first person view, all we do is we check if we're already in first person view, okay, which is this custom enum here. So pretend, let's for example just pretend that this is an integer, so let's say that first person is equal to 0. So all it does is it checks if that value is already 0, and it also checks if we're actually allowed to give game input right now. And if we if we are not already in first person, and if input is allowed, then we change to first person and we call this function, which actually performs the change. Okay, the other two functions are pretty much exactly the same. So here's the one for the shoulder camera view. Here's the one for chase camera view. Okay, that's all they do. But the key part about this is all three of them, once they've made the change, they call this function onViewTypeUpdate. So onViewTypeUpdate, this is where things get a bit crazy. So it gets the game object component from the pawn, okay, and if it finds one, then it gets the camera data from that game object component. So in the actual object component itself, there's a bunch of variables that I've exposed, which you saw me change earlier. Where are we? Camera data. There it is. Game object camera data. So this is a struct that I've created somewhere else. Naturally. Types.h. Okay, so here's a bunch of variables that I can then get to from the player controller. So I can get things like, what's the length, what do I want the length of the spring arm to be in shoulder cam view? What do I want the length of the arm to be in chase camera view? You know, do I want to have camera lag turned on or off? And the beauty is that all of these things are unique to the actor that owns this. So say I want one vehicle to have a chase camera view that has camera lag, I can turn it on. If I want another pawn to not have camera lag, I can turn it off. It's really, pro tip, it's really cool for vehicles. So if you have like a cockpit mesh and you turn camera lag on in first person view, the cockpit kind of lags behind, so it feels like the pilot is looking before the ship catches up with him, which is pretty cool. But obviously you don't want to do that in a character. So all we do is we get the data from the game object component, and then we say, right, if we're in first person, so this is a switch statement, so all it does is, okay, if I'm in first person view, I want you to set the arm length to 0 so that we're right at the eye point of the vehicle. I don't want any offsets of any kind, I don't want camera lag on, that should be a setting actually, I don't want camera lag on, and I want to set the speed of the camera lag to the data that I got from the controller. Okay, It does the same thing for the shoulder cam, the same thing for chase cam. All it's doing is it's just pulling in those variables from the game object component. And then if it doesn't find anything, so if none of these cases are true, so if I'm not in first person view, I'm not in shoulder cam view, I'm not in chase cam view, if I'm in some other abstract view that I haven't defined yet, it just does this. That's it. And all it does, once it's finished that, so it now knows, okay, so it now knows the spring arm needs to be here, the camera needs to be here, so it knows where all that is and it sets it up. The only thing it needs to do then is update the actual meshes. So if I've gone from first person view to third person view, I need to hide the first person mesh and I need to show the third person mesh to the player. So rather than do this in the player controller, the easier way to do this is through the game object component, because this already knows what the meshes are. So let's open this up. What did I call it again? Sorry, update meshes? Update object meshes. What was camera lag doing? Sorry, camera lag. So you turn it on with spring arms. Camera lag basically it means the camera sort of slowly blends to where it should be, which is quite a nice effect. You see it quite a lot. So in the object component, I've got these two references here to the first person mesh and the third person mesh. And all I'm doing is I'm turning off the ticking for the skeletal mesh so that it's not constantly updating its pose or anything if it doesn't need to. And I'm just telling the owner of the object whether or not it can see this mesh. And that's all that really does, and that is basically responsible for this, where I hit play. I don't have a first person mesh for this, but if I go into third person I can see the mesh now. If I go into first person, it's all hidden. Really is as easy as that. So as I change view, the visibility of the mesh changes as well, but this doesn't happen, this doesn't affect the other players. So if I go and play this in split screen, or sorry, I play this with two players, I can change any view at once. Let's go into first person view. It doesn't matter what view I'm in on either one. Let's move over a bit. So it doesn't matter what view I'm in on either one. They always look the same to the other player. So that's what sets the meshes. What else do we need to do? So that's basically all the code that manages like the attachment of the camera and, you know, the whole first and third person thing. That's pretty much all you need to do. So the other thing I need to do is, like I said, for my game, at any point any player can come along and, you know, hop out of a vehicle and jump into another one that might exist on the map. Okay, so when I get out of this vehicle, I don't want the camera to still be attached to it. I want the camera to attach to my new, I want the camera to attach to this guy, and also have all the same functionality. So all I do is when I possess a new pawn, I call this function attach camera to pawn, and all that does is quite literally, let's go into this in a bit more detail. So it says if there's a new pawn, so if I have a new pawn, I attach the spring arm to that pawn. I call the onViewType update function, so it does all the management of hiding the meshes and things like that, and it then gets the new game object component. Actually, it should kind of do that first. Okay, never mind. So it also gets the new game object component, so it knows where the camera should be, and it also sets the owning controller in that game object component as well. So the game object component can at any time get to the player controller if it needs to. You'll also notice this thing in here, the assert, basically says that if this other stuff takes place, but it can't find a game object component, so if I try to attach this player to something that doesn't have a game object component, then crash the game. Oh, well, it doesn't actually crash the game, but it stops the game running and basically says there's no game object component on this pawn. You need to, you need to put one on it, or I couldn't find one. So that's all that does. And this assert library is something I really want to show people, but I didn't write the code for it, so maybe I'll come back to that later. But I'll have to ask my technical manager in work if I'm allowed to share that, because that's so damn handy. It basically allows you to crash the game without crashing the entire editor, and it even tells you why it crashed, which is so cool. So that takes care of that. The other thing I need to do is when I unpossess, I also want to set the reference to null, so that I'm not calling any old functions or there's no dodgy stuff going on. Someone's just written in the chat, I'm confused between game object component and pawn. Okay, let's go over that a bit more. So, pawn, we all know what pawns are, right? So, the pawn, for example, is this vehicle. This vehicle is based off of the pawn class. So it's an object that I can take control of. The character is exactly the same. It's based off of the at lower level. It's based off of the pawn class. So it's another thing that I can take control of. The actual default pawn is I've got loads of empty classes in here. The default pawn is just a sphere that I can take control of with floating movement. That's all it is. The game object component is an actor component that I've written myself. So all the objects that I can take control of, I know that I want them to have loads of shared variables. I want them to have health. I want them to be able to carry weapons. I want them to have this camera functionality. So it makes sense, rather than doing casts all over the place, which can be expensive, and constant checks and things like that, it makes sense for me to just write a component that has all this stuff in it, and then that way, any class that I attach this game object component to has all of that functionality. There's loads of stuff in here. There's things like modifying the health, modifying the ammunition, spawning the inventory for the object, or the inventory being the weapons. Destroying the weapon classes, handles things like replication for the health and the ammo, also handles things like firing weapons as well. So if there's a weapon on there, if I hit the fire button, fire the weapon that's currently selected, and that's all it does, really, in a nutshell. So the game object component is part of the pawn, and all I do is I talk to the game object component rather than talking to the pawn, because that way I know that it saves on loads of extra overhead code. Like, if I didn't have this component, I'd have to say, okay, this is the pawn, now see if I can attach the camera to a first-person mesh. Does a first-person mesh exist? No, it doesn't. Okay, well, now do another check, and you just end up in this constant cycle of doing check after check after check, which is obviously massively inefficient. What else is going on in here? I suppose let's talk a bit about the multiplayer functionality. So this was giving me headaches for months trying to get this working with multiplayer. Two reasons for that. One, there's an engine bug that I mentioned earlier that's in 4.7. It's going to be fixed in 4.8 to do with pawn possession. But also because of the funky way that player controllers work over a network. So player controllers, the server has the server has its own version of the player controller for every client that's currently joined to it. The clients, however, only have a player controller for themselves, so they don't know anything about the other players' controllers. So it means that all this stuff with attaching cameras has to be done locally. And it doesn't. I could do it on the server, but those changes weren't going down to all the clients. It was, it's getting really screwy. So let's go into, I don't know. When you saw a server function earlier, I'll try and give you an actual example of this, so it makes more sense. Hovercraft. So this is the code class for this. No, I think it's a bit lower than this. So vehicle. Yeah. So when the minimize all this stuff. So much code. So this is where the magic happens here. So when the character walks, when the character hops out of a craft, I need the camera to attach to that new that new thing, right? So we've got here, let's see, let's walk through the chain of events. So in the input component, when I press the H key, it calls onHopOut. onHopOut basically says, can I actually hop out of this craft? Which says yes, 99% of the time. And it sets a value called the pilot wants to exit. The reason I set that value is so that if they continue pressing H, you're not gonna flood the network with loads of what they call RPCs, remote procedure calls. So you're not gonna flood your bandwidth. Doesn't affect gameplay, right? Yeah, exactly. It doesn't affect gameplay in any way at all. You know, the camera is literally the viewpoint, and the other players don't ever really need to know about it, so it doesn't matter. In fact, the other players can't know about it, so it definitely doesn't matter. So game object component is actually a class. Yep, the game object component is a class. It's an actor component, basically. And it contains loads of extra properties for anything I attach it to. So it doesn't even have to be a pawn, it could just be an actor. So I could take possession of it. Well, I can't take possession of, but I could look through the viewpoint of a crate, or I could give a crate like a massive atomic bomb weapon or something, and go crazy. So what do we do here? So we basically say this is pretty much standard multiplayer stuff. So when I press the H key, if I'm not the authority, so if I'm not the server, then I want to tell the server that I want to get out of this craft. So it calls this server function that only runs server side, and all that does is it recalls this function. So now we're calling this function with authority. So all it says is, yes, the pilot does want to exit, and then it actually physically ejects the pilot. So server eject pilot. All this does is it spawns a new pilot in the world, and then calls possess on it. And then obviously we've already seen the possess stuff. The possess stuff then attaches the camera, and that really is it. I mean, that's the whole logic of it. I mean, it's the same thing but in reverse for when we get into it. So the way I handle getting in and out of vehicles is just when I walk into them. So all I do in the character is character.cpp. I've set up a collision check here for the collision capture on the character. So if I scroll down, bloody hell, excuse me, drinking too much fizzy pop. So when the character walks into something, it tests against it. It says, right, so what have I walked into? Is this a vehicle? If it is, check if the vehicle has a pilot or not. If it doesn't have a pilot, get my player controller. Make sure that my player controller is the custom one that we've made, so it's got all the camera functionality. And then it says, okay, so now I need this to enter the vehicle. So what that does is it hides all the meshes of the character and eventually deletes it. It also turns off the character movement component, so that's not ticking anymore. And then it says, if we're the authority, get into the cockpit and take possession of the vehicle. Now, as soon as 4.8 comes out, I'll actually be able to show you that working server and client side. But for the meantime, I think I showed you earlier, this is what happens right now. So this is the server right here. Press hop out. Let's do this again. Oh wow, just noticed a glitch. Okay, never mind. So I hop out of the vehicle. If I go into this guy, hi mate. There's the character, and then I screwed that up. So I can get into and out of the vehicle. Easy peasy. Stop. But on the client side, if I try and do this, we'll see what happens. Crazy things happen. I press H, I just hovitate, I just kind of levitate in midair, and nothing ever happens. Hey buddy. Although, the server can come along and steal his craft, so it's not all bad. I've stolen it now. But yeah, the only reason that doesn't work right now is because there's a weird bug in 4.7 where sometimes the client doesn't actually get told what pawn it's supposed to be in possession of, so the player controller just sits in mid-air and does nothing. I don't know what else I can show, really. That's pretty much everything I wanted to go over. Do you know what? Next time I do a C++ stream, if I've already done the code, I'm just going to go over it, because that was so much easier. And I think it probably made a little bit more sense to you guys as well. Rather than me trying to rewrite everything and running into God knows how many bugs and glitches, it just makes more sense to do it this way, I think. If anyone's got any questions, by the way, post them in the chat. You know, on anything related, really. I'll go over whatever. Still got sort of 15 minutes left. Or if there's anything I've missed. If there's anything flashy I can show off, really. Camera data. I mean, does that kind of make sense to everyone? You know what I've done. I've made a player controller, which I know exactly what I haven't shown you all. Let's do this before we nod off. Player. So, player camera manager. This bad boy is responsible for making sure that every player has a viewpoint in the world. Thanks to somebody on Answer Hub, I managed to figure this one out. But basically, the camera manager has no idea that the... explain the basics of things at RPCs. Yep, I'll go over that in a second. Let's go over this bit first. So, the camera manager basically tries to get a camera from the pawn. If it doesn't find one, it will spawn one in the world. It doesn't try to get the camera from the player controller, so you need to override. So I needed to create an override function to tell it to do that. So all I've done is there's a function in Camera Manager called update view target, which is part of player camera manager. You know, this is a function that comes with it for Unreal. Again, I need to zoom in. Sorry, guys. Let's get a bit more screen real estate here. All I'm doing right here is if the player controller is my custom player controller, then use the view camera that I get from there. However, if it doesn't find the player controller, so if I'm using this camera manager somewhere else, then I just set the you do what the update view target function normally does. So this is the key part. If you don't have this overridden section here, the whole thing won't work. It'll all fall apart. So make sure you have that. And that is reason number 10 million why I did this in C++, is because this is not something you can do in Blueprint. So that was another limitation I ran into. And obviously, to actually use that camera manager, you need to go into the player controller and set it up there at the top. Really easy. So now whenever this player controller is used, this will be the camera manager that's associated with it as well. Let's go over RPCs and I'm allowed to share all my work with Random Public. Yes and no. I mean, this project is something I'm working on just as a hobby project, so I'm not really particularly protective over it. I do want to keep it under wraps a little bit until I've fleshed it out a bit more, at which point I'm kind of tempted to make it a community project. For two reasons. One, because I'm not that great of a coder, and two, because I see all over the place people are constantly asking about having vehicles that don't have wheels. And one thing that used to really bug me is in Unreal Tournament 3 and the UDK, the only way to do hovering vehicles really was by kind of bodging it with using like a wheeled vehicle that had no friction, which seemed like a really rude hack to me. So I've gone ahead and done an actual hovering movement component that's based on like a line trace and stuff, and yeah, it's probably 10 times more efficient than doing it with a wheel, because the wheel calculations are quite expensive. And it's all done with just 2 line traces as well, one for altitude and one for velocity, so you don't smash into walls and stuff. I do actually have some pseudocode like posted on the forum somewhere, which people could, you're more than welcome to look at that kind of stuff and pick it apart. But yeah, no, eventually, here's the hover. For example, let's have a look. People were asking earlier what kind of stuff I'm doing about physics. All this stuff here is all the math that happens purely for the hovering movement. So there's quite a lot of stuff going on here, up to about here. Yeah, there's quite a few lines of code there, and I mean this right here. I mean, look at that. That doesn't make sense to anybody. Rotation matrix, rotation cross product, scaled axis, unrotate vector. There's loads of crazy stuff going on here. But yeah, I mean, I'm happy to answer questions about it and stuff. And I'm always doing tutorials and things like this, so people will be able to steal it anyway if they're watching closely enough. Mystical poo, that makes perfect sense to me. Yeah, well, hey, when you're doing it for the first time, I wonder if the video's still on YouTube actually, but it's kind of weird. Whenever the tank, like, this is all for the self-righting behavior. So you notice that whenever the tank lands on a surface upside down, it will flip itself back over based on like a rotational kind of spring. For some reason, whenever the camera started to face the y-axis in the world, it would the vehicle would start having an exorcism of some kind, and oh my god, it took me so long to figure that out. But it doesn't matter, it's all in there now. I've only got one more physics problem to iron out and we're all sorted, and that thing is ready to go. Fresh on vector math, yeah. See, I had no idea about vector math a few months ago. All new. So let's have a look. People are asking about multiplayer stuff. Do a quick crash course on multiplayer, I guess. I won't write any code, but I guess I can maybe show you something. So obviously you guys know like the basics of replication. Like if you replicate something, it will be, it will send properties to clients and stuff. Basically, unless the way it works in Unreal is you have an authoritative client and a dumb. Sorry, you have it. That's totally wrong. You have an authoritative server and a dumb client. So the clients can't really do anything. They can only ask the server to do stuff for them. So let me try and think of an example. Game object component. Yeah. So here, for example, I've got a function that modifies the health of the actor. So what I do is whenever let me see, what's the best way to describe this? Yeah, here we go. Okay, so what I want to do is whenever a bullet hits this or whenever an explosion goes off or something, I want to modify the health of it. So whenever that happens, I just call this modify health function, and all its purpose is to just change the health based on whatever's coming in. So the only way it's allowed to do that is if the multiplayer is like an endless circle. So basically the way replication works is if you change a value on the client, that value is only changed on the client, it doesn't go out to all the other players. You need to change it on the server if you want that value to go out to everybody. And another thing is, it's always better to do that with a replicated variable rather than with doing like a function call, because A, function calls are really expensive, and well, they are as opposed to replicated variables, and B, let's say for example in like 2 frames you have a whole bunch of function calls that stack up. Maybe only some of those get through, and the danger is that your clients will start becoming out of sync with one another. So it's better to just have a variable. However, if you want to change that variable, it means that you have to then do it on the server so that every client gets the same version, if that makes sense. So, I mean, it's really easy to set up. This function here, modify health, let's open this up. All it is just a standard function, a Blueprint callable function, so, someone from Blueprint can call this as well, and it will handle all this for them. All this does is this all it does is it says, right, I want to modify the health of this by this much, and I want to subtract it. So, goodbye, go away. So, all I do is I check to see if the owning object has authority, aka is this happening on the server. If it's not, then I basically do this here, server modify health, which is this function, which only runs on the server. Okay, so this function here only runs on the server. The way you sort that out, so this is called server modify ammo, and if you look in here, server modify ammo is right here. So it's got the, in the U function, it has to be a U function, it's got the server tag in it, which basically means this function will only run on the server. Like, it won't run on a client, clients won't be able to do anything. It's an authoritative procedure call. It's also reliable, so long as you're not saturating the bandwidth completely, you can be sure that this call will get through to the server. And with validation, because everything needs to have with validation on it. Using the validation stuff can be a little bit complicated, so it makes sense to just put with validation on and just accept that you have to do it. And all the server function does is it just calls this function again, but it's now running it on the server, so it skips this and it goes straight into the stuff that it should be doing. So all it does is, if I'm adding health, then it sets the health variable to whatever it is plus this much health, or if it's not, then take away the health. Easy. And then, because current health is a replicated variable, eventually, I say eventually, within a few milliseconds, depending on latency, all the clients will get that new health variable, so they'll know what their health is. Does that explain it? Is that good enough? Another thing that's worth noting, I suppose, in 4.7